So last time I have given you one question, okay class, and in that question I hope that everyone has written that question, and I just want to repeat that question again, okay. And question says that a physical quantity P has been written here, okay. Last time I have given you one question and I am again repeating it, that the percentage error of the measurement of A, B, C and D are 1%, okay, 3%, 4% and 2% respectively. Full stop. Find the percentage error in the quantity P. Okay, there is one quantity P. For that we have to calculate the percentage error. Okay, and further, if the value of P calculated for the above relation comes out to be 3.763, to what value, that is another thing. Okay, till here I have written that if the value of P calculated from the above relation comes out to be 3.763, the value of P has been given to us, and some of the percentage error regarding A, B and C and D has been given to us. Okay, so let's try to find out. This is the relation of P which we have written last time, and P is equals to how much? A cube, that's all the question, B square and square root of C B. Okay, we have seen two methods last time. Last time we have discussed two methods, that by taking log on both the sides we can calculate. Okay, and then we need to differentiate. Then we need to differentiate by taking log on both the sides. And some other practical way I have taken analogous to the things which we have discussed in product terms. Okay, in product term we have calculated Z is equals to AB, and for that we are getting the fractional error corresponding to Z like this. This is the maximum error corresponding to Z that we got last time. Similarly, on this basis, analogous to this, we have derived the expression of fractional error regarding any physical quantity. Those have some suitable powers of them. Okay, so instead of writing these things as such, we just take the consideration of the power also which are on it. Okay, for example, in analogous, in the same way as it has been written here, I am writing the fractional error for P regarding the above expression. Okay, so first we what need to do? We need to write the powers on the left hand side, on the right hand side, and then delta A upon B. That is the fractional error corresponding to A plus B, and regarding B, what is the power? 2 delta B upon B, and plus for maximum error I am writing. Okay, this is the maximum possible error about which I am writing. Okay, and for C it comes out to be half delta C upon C plus delta D upon D, because there is no power on D here. Okay, so now what we do? We have written in the same format as we have derived earlier for multiplication of two physical quantities. Okay, so now what we do? This is the value of maximum possible error. Okay, this is the maximum possible error. Possible fractional error. Okay, this is the fractional error. I hope that you all are doing the revision of the previous topic which has been taught, and on that basis I am writing all these things. Okay, so instead of taking any negative sign here, I am taking what? All the positive signs. So further what we do? Further what we shall do here? Okay, this is the value of maximum error. For percentage error, we need to multiply 100 on both the sides. Okay, so for percentage error, what we do? We multiply 100 on both the sides, then we will get like this into 100. Now this is the percentage error regarding P. Similarly, if we are multiplying 100 on the left hand side, we need to multiply 100 on the right hand side also. Okay, 3 into delta A upon A into 100 plus 2 into delta B upon B into 100 plus into delta D upon D 200. This is what we can write. Till here everything is clear. Now you can see that this is the percentage error in B. This is the percentage error in A. This is the percentage error in B. This is the percentage error in D. And these thing has been given to us. Okay. Percentage error in A has been given to us according to the question. It is how much? It is 1%. Okay. It is 1%. So what we do for percentage error now, instead of writing this expression, I am using the short form. Percentage error in B will be how much? 3 into percentage error in B. Percentage error in A is how much? 1%. Plus 2 into percentage error in B. And percentage error in B has been given. It is how much? It is 3%. Okay. Similarly, percentage error in B has also been given to us. Percentage error in A we have written, B we have written. Okay, and there is one more term, na? C term is also here, na? Plus half delta C upon C into 100. C here. And if we multiply it by 100, then it comes out to be delta C upon C into 100. So, okay, we are having these terms. And percentage error in C is how much? Percentage error in C is percentage error in B is 3%. Percentage error in C is how much? 4%. Okay. So half into 4%. And percentage error in D is how much? Percentage error in D is how much? Percentage error in D is 2%. Okay. Plus 2%. So this is simple mathematics now. Okay, this is simply mathematics. So mathematical calculation is required. So 3 into 1 plus 2 into 3 plus 2 cancels out 2 times. Okay, this cancels out 2 times. So 2 plus, so 3, 6 and 4. This will be how much? 6, 4, 13%. Okay, this will be percentage. So 13% will come regarding the percentage error of B. Okay, this is what we have been asked to calculate. So here is one more question just based upon that error analysis, and it says that a body covers a measured distance of 13.8 plus minus 2 meters in a measured interval of time of 4.0 plus 0.3 plus minus 0.3 seconds. Calculates its speed with error limits. Okay, we need to calculate the value of V along with the error limit, that is the change in the velocity. Okay, that is the error limit. So before starting our error analysis, it is very important that we should know the formula in which we can relate the velocity with respect to what? Distance and time. Okay, this S denotes the distance and this denotes the time. So let's do. So what we do in this case, in such type of the case, okay, in such type of the case we can do like this: delta V upon V is equal to delta S upon S plus, because we are talking about the maximum error. Okay, this is the value of maximum fractional error. What we do, we know that when this t goes in numerator, it will result into t to the power minus 1. And if we start taking log on both the sides, then a negative sign may come here. But we are talking about the fractional maximum fractional error. Okay, so instead of taking that negative, we take simply delta t upon t with positive sign. Okay, since these terms do not have any power, so there will be no contribution of power just before the fractional error of respective terms. Okay, so now further what we can do, it has been given, okay, something has been given to us. Okay, now we can easily calculate the value of V here. according to the above expression, according to the given expression, we can calculate the value of V here. So what will be the value of V in this case? Okay, since you are having this distance term with you, this is the distance term, okay, along with its error. This is the time term along with its error. So here, as I told you earlier, that this format, according to this format, this shows the actual value of our observation, and this shows the error. Okay, this shows the actual value of our observation, and this shows the error. Similarly, for time also, this will be the actual value for time, and this will be the error corresponding to the time. So according to this formula of velocity, according to this formula of equation number 1, let's name this equation 1, name this equation number 2. तो अगर हमें actual value पता करनी है, if we want to calculate the actual value of V, then we need to take the actual value of distance term also, and we need to take the actual term of time also. Okay, therefore from equation 1 we can write, what we can write, V equals to distance upon time, that means actual value 13.8 upon 4, 13.8 meters upon 4 seconds. This is what we can write. And what it comes out to be? It comes out to be near about 3.45 meter per second. This is the value of the velocity which I am having. Because the value of the velocity is very important. Why I am calculating the value of velocity? Because we have been asked to calculate this delta V value. Okay, we have been asked to calculate delta V value. Instead we write that delta, Kronecker delta, or this delta. All are same. We have been asked to calculate this value, so this should be known. That's why I have calculated the value of V. Now our main attention should be here on the right hand side. So what we can write? So delta V upon V, again from equation 2. Okay, this is from equation number 2. Equation 2, what we can write? Delta V upon V, is it visible now? Is equals to how much? Delta S upon S. So V we are having, it is equals to 3.45. But I round off this entire term. I have rounded off this entire term. In next lecture we will be studying about the rounding off of figures. So just you need to remember that we are using a very small application of round off term here. So if this 3.45 get round off, so it will be converted into 3.4. Okay, you just need to remember, and in our next lecture everything will be clear. Okay, so just you need to put the value of the round off term. Okay, so what is the value of the change in distance here? What is the value of the change in distance here? It is equals to 0.2. Okay, that is the error corresponding to distance. And what is the actual value? It is 30.3. Okay, and plus what we need to do, delta t. What is delta t? Delta t is 0.3, and 0.3 divided by 4. Okay, this is what we have. Now further, if you solve this, then how much it is coming? Just tell me fast.
So 0.014 plus 0.075.
Might be coming this much, okay? And it comes out to be 0.09. So now you are having this V value. Now you need to calculate delta V. You are having the RHS also, okay? So instead of solving down, just to be in camera, I am solving here. Okay, I am solving here. So you are having delta V, and you are having V in denominator. It is 3.4. Okay, so you can take this entire term also. Okay, you can take this entire term also if you are multiplying it with this number, because after decimal there are two numbers or two digits, so you can take the two digits also while you multiply. Okay, there will be no much variation. Either you take 3.4 or you can take 3.45 also. Okay, but I am taking here 3.2. Let it be. So it will be multiplied with this, and delta V here the number of how much? How much is the the answer which is coming there? It comes out to be 0.3 meter per second. This one an answer should come. Till here it is clear. So that what we have calculated, that what we have been asked to calculate, that we need to calculate its speed along with its error. Okay. So what will be the required expression of the speed? Because with error limits, what will be the value of speed? We can express velocity as this. The main value, it is the actual value. It comes out to be how much? Here we have calculated. Here 3.4 plus minus how much? 0.3 meter per second. In terms of error, I have written the physical quantity velocity. Okay, that what we have been asked to do. Everything is clear till here? Raise your thumbs up. Okay, that's good.